lab. So I think Akhilesh ji will only continue the session. Akhilesh ji, we can start now.
Sure. Screen is visible for everyone and my voice is audible for everyone.
Yes,
Okay.
yes, it's visible and audible.
Okay.
Your voice is audible.
Okay, our this session is on model-based design using Simulink. Means how we can design any kind of system on Simulink. So before in first session, some people joined late, so they had a query that how to access data in MATLAB from file, right? So I will take just 5 minutes. I am switching in MATLAB how to import data in MATLAB. So this is a MATLAB environment. Let's say that I have data in text file or in some other file formats, but I don't know how to import that kind of data. So here is the import tool which you see. Fine. Just click on this import tool and search your data wherever your data you have. So I have here. Okay. Let's say that I am going to import this CSV file. So when you select that, you will get a new window like this in MATLAB. Okay. Now here you see that what is the range of your data. You can select it from here or you can select all. Further, you have an option that are you going to import data as a column vector, means each your variable will be saved in a different vectors. So whatever number of columns you have in your Excel file, so number of column vectors will be also generated in MATLAB. So numeric matrix we use when I have all numeric data. String array means single inverted comma or double inverted comma. You may say as a character, if you want to load your all data, you are going to choose string array. If you use parenthesis bracket, so that is called cell array. So if you want to import your data as a cell, you can choose from here. Okay. So the recommended is table, because when you import your data as a table, it will create an object. In object you will have all column names, you will have all characters also, like here you see that we have characters also here, right? So if you import this data as a matrix, it will be assigned as a not a number. So this is the issue if you use numeric matrix. So you choose numeric matrix when you want just a numeric data only. In my case, I am going to choose table, and when I click on this, I have here table, you see, as a dat file, right? If I give a command summary and this table name, it will give me a summary of all columns which we have in that Excel file or that CSV file, mean, median, max of all variables which we have, right? Further, for automation purpose, means what will be a code for that, right? So here is an option that you can generate a live script file, function file, depends on you. Further, you see here that if you have some missing data which cannot be imported, so how you are going to replace it. So here you can define either a constant with some constant or not a number, depends on you that how you are going to fill that missing data from here. Okay. So further, what I am going to do, I am going to generate a function file for that. You see here that function file is generated for that, right? So what will I do? I will save this function file, and here I will provide a file name, and when I provide my file name as an input to this function, my data will be imported in MATLAB again. So I am going to save this. Let's say that I am going to save as import file, and now you see, let me minimize this. I have that function here as an import file, right? Second thing, my Excel files are in this folder. It is not in a current folder, right? So if I import any file from different folders, I require to add this folder in a path. So what we can do in this case, just right click, it is already added. So it is asking me remove from path, so it is already added, so no problem, it is so what you can do, just right click, and from here you can add this folder in your MATLAB directory. Okay. So these are my files which I have here, you see, in this folder. So if I have to import this data, let's say I am going to import this data as a dat1, and I will use this function which I created. Just wait, this one, import file. So import file, okay, and your file name. So it's saying that it is undefined. So let me check that what that file name is. Okay, what we can do, we can just switch to this folder, and we can write that file name dat.xlsx. Let's say I want to import this, or CSV file if I have. Okay, so we have here CSV files as well, 2007 dat.csv, right? And further what you have to do, just when you enter it, this CSV file will be imported here in the workspace. Fine. Next thing, I was showing some live script analysis, that how you can use live script for analysis. So this is my table here. Okay, let's say that I have to do some kind of pre-processing on any kind of table. In that case, what we can do, we can use this live script. And further, if you go here in task, there are different kind of processing here, right? You can see here. Let's say if you are working on audio data, then if you want to extract features from audio data, you can use this template. In my case, I am going to use smooth this data. Now from here I can select my table, and from table which variable I am going to smooth it. So in this case, let's say I am going to choose mileage. Now here you have an algorithm, that what algorithm are you going to use. Let's say I am going to use Gaussian filter, and further if I want to increase some smoothing factor, I want to remove that spikes which I have here, so I can increase this smoothing factor in that case. Now you see that here two graph, we have one dark blue, that is original data, light blue, that is original data, and dark blue is a smooth one. So in this way you can do analysis on live script. Already I shared that recorded webinar, you can go through that. Okay, and one thing more, you see here, if I click on this import, you can see that what kind of file formats are supported here. So if you have this kind of file format, then directly you can import in MATLAB. Otherwise, if you don't have this kind of format, so there are some functions in MATLAB like fopen, fclose. So you can use that kind of inbuilt function in MATLAB to access data in MATLAB. Okay, I'm switching here. So if you have any questions, so you can ask me at end of the session. You can write in a chat box during the session. I will reply after the session. Okay, so first of all, why do we do modeling and simulation? That is a big question, that why do we require to do modeling and simulation using Simulink, right? To get a better understanding of the systems, when you have to design any system physically, instead of designing physically, first we require to design it virtually, and we do some kind of testing on that system, and the output which we want, if you are getting that output, then we are fine with that, and we can go for the physical modeling. That is a main concept, that why we do a system modeling in Simulink. Okay, more to find out the what kind of structure I have for my systems. Interface connections means whatever system I have, it is interfaceable with user data or not. Of course, robustness of the system also with different environment conditions, like if I have to design any kind of controller to launch a rocket, so you see that their system environment is changing on the way if rocket is launched, like atmosphere can be less, temperature can be increased and decreased. So all that considerations we can take in Simulink to design my system as a robust system. Okay, also we have to test that what is the response to the user input, and why is that important. Find and fix bugs early if there are some kind of bugs. So virtually we can do this. Physically, if you are designing from the beginning, you are using some kind of hardware, some kind of components. If you are getting the issue, then it is impossible, almost it is impossible to fix the bugs there, right? So that's why we use Simulink again for that. So test system under conditions difficult to replicate in the real world, right? If it is, sometimes it happens that it is very difficult to identify the conditions and issues in the real world, but virtually whatever you want you can do it using Simulink. And why again this is important? Because early testing and fixing bugs early saves a lot of money. Of course it will save a lot of money and down to the road, right? So this is a traditional development process for system modeling or model based design. Let's say that if you are not using Simulink, just if you have to approach for model based design. So what you will do, first of all you will collect data, means what requirements, data as a requirements, that what are your requirements. That is very difficult to do manually. You require different domains. From different domains you have to collect the data. If you are working on mechatronics, then you have to know that what electrical component you require, what mechanical component you require. That is a very hectic task to do as a traditional approach, right? Paper specifications. Okay, when you collected data, when you collected requirement, writing in the paper, maybe there can be some errors also, and it is very difficult to integrate with different domains also if it is written in the paper. And further, okay, after paper specifications we require to design a physical prototypes, means to test your model. So you are going for like CAD and CAE solutions, right? That is also very incomplete and inexpensive, because there is no such kind of software that which will provide you 100 toolboxes. Let's say you want to design, and further you want to after designing your system, if you want to do a predictive maintenance kind of things, how will you do in a single platform, right? Manual coding. After that for that prototype, physical prototyping, we require to code it manually. Means if either you can code, if you are designing a filter, then you can code as SDL. If you are designing for embedded hardware processor, then you require to design in a C++. You have to write a code, right? So that is also a very hectic task. If you don't know how to write a C, even if you know, designing a single filter in a C, you can imagine how much time it will take. So much time consuming it will be, right? Traditional testing. Further, traditional testing, whatever testings are available, that kind of testings we require. So that integration issue will come. Let's say that you design the electrical part, then how to interface with mechanical part. Again, there is a big question here that how we can do all this process. People do, it takes a lot of time, 3 years, 2 years, 4, 5 years, like this, right? So these things overcome through MATLAB. About requirements are linked to the model. Why it is linked to the model? We have already mechanical components, we have already electrical components, already requirements are given in the MATLAB. You don't require to collect from any other places, right? Second thing, details is added from the specific domain to refine the model. Okay, if you are designing a DC motor, so already DC motor component is available in Simulink library, and everything is specified that what parameters you have to give to that motor, right? So already it is specified, already requirements are available in MATLAB. 100 toolboxes are there, more than 100, you can interface with any. Next, testing algorithms against requirements. So for that also it can be done by simulating your model. And if you want advanced kind of testing, we have a Simulink test, Simulink check, Simulink coverage. So you can test your model with some standards. Like if I am talking about EMI generation from mobile electromagnetic interference, for that there is an international standard that is called FCC. So that kind of things also you can interface with MATLAB, and within that requirement you can test your model using Simulink. And further, real-time testing. Real-time testing means you are going to deploy in a hardware. So if you are using Simulink, you don't require to learn SDL or Verilog kind of code, just you require to know a basics or maybe not. In a single click you can generate. I will show you how you can generate a embedded code or C++ code for model when you design on Simulink. Now what is Simulink? We talked about model based design, then what is Simulink now? So Simulink is a environment to design any kind of systems as a graphical way. Like you see that some blocks here in this diagram. Now, these blocks are already available in the Simulink library. We require to add that blocks, join that blocks, provide the parameter and run that. That is the Simulink. Model based design means design your any kind of plant virtually in Simulink, test it, then generate a code for different kind of hardwares. I will show you how you can do this kind of tasks also. MATLAB and Simulink work together. When you use MATLAB and Simulink together, you combine textual and graphical programming together. So there is an option in Simulink. If you don't want to use block, whatever input you have from Simulink, you want to write a MATLAB code for that. So you can use MATLAB function block or some other blocks you can use to write a MATLAB code also. Directly use the thousands of algorithms that are already available in MATLAB, like in control system, like in DSP, communication, machine learning, deep learning, depends on you. And advanced controller, if you want to design again as a graphical way and easy way, you can use state flow also for that. Okay. These are some applications in Simulink which you see. Wireless communication, like if you want to design 5G for 5th generation of mobile communication, that is a NR 5G new radio. Right now we have a 4G, so when you see it is a LTE, long term evolution. When 5G will be installed, you will get a signal as a NR new radio. Okay. Motor and power control systems, signal processing, any kind of signal processing system if you have, you can design in Simulink. Robotics works you can do in Simulink. Advanced driver assistance, like if you want to design some kind of ADAS system, that also you can design in MATLAB, because right now we have a automated driving system toolbox, vehicle dynamics toolbox. Either you are designing a electrical vehicle or you are designing a mechanical vehicle or hybrid kind of vehicles, and if you have to create scenes also for that, means create a hindrance on the road, how your vehicle is behaving on that. So that kind of things you can design very easily. Let's say you want to design some kind of applications for surveillance, if you are designing some kind of applications for tracking, so image processing and computer vision kind of models also you can design. Plus IoT, already we discussed about IoT also. So in future if you have any kind of session on IoT, then we will discuss on IoT also. Let's say that I have to design one solar panel, so it will move with respect to the movement of sun. Right now you see that sun is here, and when sun is moving, but this panel is not moving. If this panel will not move, we will have a less efficiency. For high efficiency, we want that sun is moving with respect to sun, my panel will also move, so we'll get the higher efficiency in that case. So this system we are going to design in Simulink. Okay, so for that, what kind of subsystems we require? 3 subsystems we require. First, we require a controller to control this motor, whatever errors are coming. We require to design a motor to control this panel, to rotate this panel, and we require to design, of course, a system that is panel. So these things we are going to design in Simulink. So first of all, we are going to design motor and panel. So first process, I will start from the basics, so you will be aware that how you can design that motor and panel. Okay, these are the equations for that. So this is a rotation of panel equation, means we are giving some kind of torque value. Based on that, my panel will rotate. So of course it is a rotational kind of system, so we require to extract the theta value from that, right? What is the angle that which is rotating from 0 to 270 degree. Further, this is a motor equation. So first of all, we will start from the panel here. Okay, I am going to switch in here in MATLAB. So first of all, let me show you a library, that what kind of libraries are available in Simulink. Okay. You see that this kind of libraries are available in Simulink. If you don't know, if you are using first time, when you open the Simulink library, it will be opened like this. Okay. So here you see this part. That is a part of a Simulink if you don't have any other toolboxes. But if you have a Simulink, so in that case you will get all these libraries. Like if you have to use PID controller, integrator or differentiator kind of things. Dashboards, like some gauss are there, some switches are there. Okay. If you have to use some kind of sources, here we have sources available, like signal editor, sine wave. So different kind of sources are available there. Okay, you can choose any sources from there, depends on you. Now to visualize the output on any point, we have a sync group for that, like display, floating type, scope. So this syncs library is used to display our output or save our output. Okay, and these are math operation blocks which you see: addition, subtraction, multiplication, division. You can use these blocks to design your mathematical model for that. And apart from this Simulink, you see that there are some other libraries available there. If you have a aerospace block set, you will get all these blocks to design a aerospace dynamic system, dynamics of that aerospace. Okay, these blocks are available. Further, if I go more below, here is a communication toolbox. Like if you have to design a channel, then you can use this kind of blocks. Equalizers are available, source are available. If someone is working on massive MIMO, multi-input, multi-output antenna system, you can choose at these blocks also. So these are the blocks if you have that toolboxes. If you have to acquire images, live images, you can use this block. That is a image. This is a part of a image acquisition toolbox. Okay. So these are different libraries are available here. So how to start from Simulink if you are a beginner? Let's say you don't know that how to start. So here is the option. When you click on this, then Simulink will be open. A Simulink environment will be open. Or just here you have to type Simulink, and you will a Simulink will be open. So Simulink will be opened first time. When you open the first time, it will look like this. So here you see that there is an option that you can start from the blank model, or if you want to create a subsystem, or if you want to create your own library of Simulink, then you can start from blank library. Let's say multiple people are working on a single project, so you can create a Simulink as a project also. You can interface with GitHub, you can interface with other platforms also in that projects, right? Now let's say I have to generate a SDL coder. So what will I do? I will open this kind of GUI, user interface. Why? If I have to generate SDL coder, we require some kind of configurations. So when you use this blank model, automatically all configurations will be done for SDL coder. Okay. Same for the embedded code. This is for the FPGA processor, and this is for the microprocessor. So if you want to generate an embedded code, and if you want to deploy an embedded hardware, you can choose from here. Okay. Now I am going to start from blank model. I will click on this. A blank model will be open like this. Okay, just wait a minute. Let me switch first of all here. Fine. So I am going to open the Simulink again, and I am going to open the blank model for you. Okay. This is a user interface, graphical user interface you may say, or you may say the Simulink environment where we design any kind of Simulink system. Okay. To get the library blocks, just you have to click here, library browser, and from here you can add blocks. So I will let you know how to add everything and how to do this process. First of all, I need this equation, right? Panel equation, right? So I have written somewhere that equation. Let me annotate that equation first of all. This is my equation which I am going to design it. Okay, here I have this Simulink. Now here if I have to write some kind of comments, here is the option you see in the left side, left corner here. If I want to write a comment somewhere, just I will use this, and that equation I am going to paste it here. And I want to make it as a 18 more, so it will look like more bigger. So let's say 22 and make it bold also. So this is the equation which I am going to design. So it is a second order of differential equation. Okay, T is the torque and there are some other parameters here. In this equation you see, to solve for theta we require two integrators and some kind of other blocks, like Kd is a multiplication, that is a gain, d theta by dt it is multiplied by that. Okay, so first of all let's collect all data. See here T is minus, so T is a torque, we require some kind of blocks, constant blocks also. So how to add these blocks? First of all we will start from integrator blocks. In my case I am going to start from integrator block. So what will I do? Just I will click on library browser. Where I will get integrator I don't know, you can search it from here, just an integrator, and it will show you integrator blocks. But in my case I know where are integrator blocks, that is a part of a Simulink. So let me tell you the blocks which I am going to use right now, every blocks will be from Simulink library. So I need a integrator block that will be in a continuous one. If you have discontinuous system, discrete, you can use from here. Okay, or you can go in a discrete. So there are discrete integrator and differentiator and controllers. Discretes are required to generate an embedded code as well. So here I am going to use this integrator. Okay, I have this integrator. I need one more integrator. Why? After let's say that here I have y triple dash. Okay, here let's say I have y double dash, no? It is the second order. Let's say here I have y double dash. Okay, let me make it big size. Fine, so it will be visible for you, for everyone. That is y double dash. After one integration we will have an output as a y single dash, and one integrator if I add more I will have y or theta. So instead of y let me replace as a theta. So simply here I am going to write theta double dash. Okay, this is the theta. Okay, so what we can do, again I will go here and from here I can add this block after right clicking on this. But I don't want to do that. What I can do, I will right click on the mouse and I will drag it here like this and I will paste it. I have this. Okay, now in here what output we have? Theta single dash, and I am going to increase the size of this as 18. This is theta single dash. Now here the output which I will get, that will be a theta. I am starting like this. Okay, so I need a scope. Now you see scope you will get in a sync because we have to visualize our output. So here we have scopes. So again I know the block name, so I am not going in library again and again. Just I will move my cursor and I will click somewhere and start searching like scope like this. I will get the scope here. So I am going to use this scope and I am going to add this here. Now we are going to write the equation here like this. So first of all you see here T is one equation and this is one more equation. We require some kind of sum blocks also to add this too, right? So let me go in library. In math operations there is a one sum block. This I am going to use this sum block. Okay, I have this sum block also. So you see here T is minus, so one will be positive and another will be negative in that case, right? So I will double click on this block. One is plus and let me assign another as a minus. I have one sum block also. T, I need one constant block also. You see T is minus from that. So constant block you can get from source or you can search here if you know the block name. I have one constant block also. Now you see we require to multiply KD and 1 by J. I require a gain block also. Gain block you will get from math operations group. Okay. But if I know the name, I can search it here. Just you have to move your cursor, click and start typing, you will get. So I need a 2 gain block. One for 1 by Z, another for KD. I am going to drag it here and I will have 2 gain block right now. Now I am going to write the equation. So first of all you see that T is minus. Okay. So let's say this is my T and I am going to add T here, T minus this equation. So this is T. Now let me define it as a T. So to define this as a T, just double click on this, go here, create a variable. So you have two options, two workspace are there, model workspace and base workspace. Base workspace is of MATLAB, model workspace is of my model. So you have two options, you can create either a base workspace or model workspace. So I will show you where model workspace is there. First of all, I am going to create a base workspace. So it will take a little time. So like this, step by step we can create it. Okay. So here I will just provide the name of that variable T and create. As a default value is 1 right now. So I am leaving it as a 1. Now we have T here. So why I am giving a character name? So I can identify that this is a T, right? Further I am going to join this. Now you see here in this KD d theta by dt is minus. So d theta by dt we are getting here, right? And KD is multiplied with that. So what I am going to do, by Control R I am going to rotate it and I am going to name it as a KD. So this is KD. So again what I can do, I can go here, just wait a minute. Create a variable and give a name as a KD and create. Okay, now we have KD as a default value 1 and I am going to add it here. Now you see from here what we are getting, d theta by dt into KD, and it will be minus because we have here theta double dash. Okay. Now next you see 1 by j is multiplied with t minus KD d theta by dt. So here you see we are getting t minus KD d theta by dt. We are getting this. So we are going to multiply with 1 by z, this gain block, and let's modify this. From here we can modify this also. Let's say that its name is z, as a default value is 1 again. I will let you know how you can change this default value also. Okay, so here will be, instead of z it will be 1 by z. Fine. Model is done. The model which we wanted, we created, right? You see here, here we are getting this whole equation and here we are getting theta value. Fine. And here we have this torque also. Now the variable which I created as a t, as a j or as a kd, this variable will be appeared automatically in a workspace. And if I want to give some different torque, let's say t is equal to 2, now it will take t is equal to 2 instead of t is equal to 1. Now what is model workspace? If I click on this modeling and if I go in model explorer, this is here you can explore every objects of the model. Okay. So this is the base workspace and this is model workspace. And you can write model workspace as a .mat file or as a, if you have a script file, sorry, this is a mat file, or if you have any MATLAB file already, or if you want to write a MATLAB code, so here you can write a MATLAB code also. So when you open this block, I mean this model, this code will be executed. Or if you have already written, you can give a path of that mat file. So that is a model based workspace. Okay. So here you can use this, utilize this model explorer for that. Okay, now what I am going to do here, I am going to visualize data on this scope, and next I want to log this data also. So here is the option, select and right click and log selected signals. Okay, so you see that you will get some kind of wireless kind of sign here. So when I run this, my data will be logged. So here now next here is the option that for how many seconds are you going to run this model. So as a default I am choosing 10 seconds. Okay, later things we will discuss later, that what things more are available. Just let me run this. So this is the theta, this is the angular distance if I am providing torque 2. Okay, and if I go in data inspector, the data which I am logging here, it will come in a data inspector. See, this is the integrator output, this one, right? Now I am going to change the torque value from here. See, that is the user input which we are giving, and we are checking our outputs. So now let's say I am going to give t is equal to 10. Now again I am going to run this model, and I want to check that what is my output. Is the output which I want I am getting or not? Because overall what we have to get, that theta value with respect to sun movement, right? So like this we can check. And further, if I go in data inspector, so you see this is the latest one, and older one which we ran when t is equal to 2 it will be saved in a archive file. And if you want to plot this also, we can compare. See, this dark blue which you see when t is equal to 4, sorry, it was 5 I guess, no 10, when t is equal to 10, this one, and when t was 2, you can see this. So what we see here with respect to time, when I am increasing the torque, my panel is rotating very fast. But what we have to do, what is our agenda, that my panel will rotate with respect to the sun movement, right? So later we will discuss that how we can give input of original sun data, means movement data, and how we can optimize as a reference. Okay. Now this is my first system. What I can do, I can create it as a subsystem for that. I will select this all, and here you see that I have an option to create a subsystem. So it will be a subsystem, and let me name this is as a panel. So this is my panel which I designed. Fine. And further what we can do, here you see that if I go inside, this is the input node, this is the output node, right? So let me rename this input node as a T, that is a torque. Okay, so if I go back, here you see that T is written, right? Same, if I go here, let me rename it. Why I am renaming all this? Today I designed this model, maybe after 10 days I will forget what is that, right? This is theta. So we have a subsystem. So if your model is complex, you can test your model as a, first create as a subsystem, test it, then create another, right? Okay. So I have this model. Now let's say I have to generate a code for this. I have to generate a code and I have to deploy on hardware. I have to check the system. Let's say, so I am not going to interface, but how to generate a code, that I can show you. So first of all, as a default, this is a variable step, means floating time. So of course in processors we require a fixed type of codes, right? So what we can do, you can go here in this setting, okay? A configuration will be open for the Simulink. Later we saw for the MATLAB, here this is the configuration for Simulink. Instead of variable step, I am going to choose fixed step. And here you can provide the fixed step value. If you don't provide any value for fixed step, it will take automatic. Okay. Now, if you have to deploy this system on any hardware, let's say, I will go in hardware implementation, and from here I can select any hardware. So instead of system, if I had a controller, let's say, and I want to deploy that controller on Arduino, Raspberry Pi, or if I have to deploy on Xilinx, so I can choose from their hardwares as well. And how to deploy it? That is the question again. Okay. So okay, I selected as a fixed step. Fine. Now if I have to generate a code for that, I can go in app, and from here I will go move here, just code generation. So two options, there are different options. If you have to generate a auto SAR standard codes, you can select this. SDL coder, you can select this. PLC coder, you can select this. There are different testing also. I want to generate a simple C code, not even a embedded coder. I don't have hardware. I don't have to deploy an embedded hardware. Just simple C code I want to generate. I will select this, and a new tab you will get as a C code. Further, here is the option build or generate code. Okay, so when we use build, if I want to run that model on any custom hardware which is interface with my laptop, so I have to select this, then I have to go here, build this model. What it will do, it will run, one model will be run on my run on my hardware, and one model will run on Simulink, and it will compare the both output. If I am happy with that, then I can go for further testing. So in our case, we are going to generate a code only. Okay. Now you see that process is started. Code generation process is started. So this is the way how you can design your model, and for testing also how you can generate. So code is generated. I want to check that code. I will just click open report. If I open this report, I will get that my original C code. Here you see Untitled, because name of my that Simulink model was as Untitled, and you see that these codes are generated. See, and manually if you have to write code for that panel, you had to write around 300 lines, and how it was complicated for that, right? Not only code is generated, to compile this code on C compiler, header files are also generated. What kind of data files are available? Every file is generated which are required to compile this. Okay. So okay, this was about the panel, how we design. The next part is design the motor. So for the time being, I am not going to design. I have that controller already. Sorry, designed motor. So now you got that how you can design a Simulink model here. I am going to close this. So you see that this is the panel. So these are the images. There is an option if you want to import any image, just click on this. You can import images also. So here you see motor equation. This is the motor equation, and this is the mathematical designing of that in Simulink. Okay, fine. Now I am giving some voltage here, some velocity it will get, that panel to rotate, and position it will get. Okay. Here it is the feedback to the torque, and based on that feedback of velocity, torque will be generated and this panel will be rotated. So here is the model which we designed there before. Okay. Now I am going to run this for 10 seconds. I want to check it that what theta value is coming. This is the theta value, and if I go here, that is a velocity, that is constant around 7 somewhere. Okay. Fine. Next, let's switch here. So we saw that how to design a panel. Based on that, in the similar way, you can design the motor and you can connect both subsystems. Next, we are going to design a controller. Okay. So why we require to design that controller? See here. Sorry, just wait a minute. See here, right now the panel direction is here and sun direction is here, right? Now you see, this is rotating now according sun, that is fine. You see there is some kind of delay. First sun is going here and this panel is going little bit late, right? It is following the sun little bit late. So this is the error. We have to minimize this error which we are getting. That's why we require to design a controller for that. Okay. So let me switch here and design the controller as well. So let me run first and check it if it is working proper. Now it is working proper. I am going to design a PI controller for it. I will explain why PI not PID after designing this. You can design PID, but why not PID? That is a big question again. Why PI not PID? Okay. So here I will go and I will go in library, and from here I am going to use PID controller from here. Okay. That is the controller which we are going to design, and I am going to interface it here, and we require a negative feedback for that. Whatever error of position is coming, it will go back to PID controller, right? So in this case again I need one sum block. Let me maximize this. Okay, one will be plus, and for negative feedback one will be minus. We have to apply. Okay, that's all, and I am going to connect this here. Now this will go as a feedback from position. So from position feedback will come and this PID will minimize that. Instead of this constant, I am going to take step function, means a unit step function. Okay, I am going to add this also. Now in this case what we have to do, now this will be not a voltage, this will be a reference data, that is the sun data. Okay, now you see this is a step function as a reference, and this is my controller. So whatever error is coming here, it will go as an input to PID controller. PID controller will tune that error, it will try to remove that error, and it will give to the motor. Okay, this is the main agenda which we are going to see. So I have to check this reference also. Just select this and right click mouse and move this and add it here somewhere. See, it is added here. Now for 10 seconds I am going to run this, and I am going to check after adding controller how my system will behave. Means the reference which I want as a step function I am getting or not. I am not getting. This is my reference which I wanted as a step function, but what I am getting here, this one. So it is not following the things which I want, the output I want, I am not getting that output. We can tune that PID controller. To tune this, I am going to just click on this tune PID tuner, and I am not going to select PID, I am going to select PI. Fine. And I am going to open a tuner. From here you can open the tuner to tune that. Means you can increase or decrease transient behavior of it, speed of it, depends on you. So this is an app where we can tune our system. So right now this is a step response of the system, and this is a tuned response, and the dot dot which you see, that is a block response. Okay, here you can make response time slower, or you can increase the aggressiveness of it, means transient behavior, more robust. And here you can see parameters value, that is what is the parameter value of P, means Kp, Ki, Kd, and what are the rise time, settling time. Now one question is more, we will discuss that if you have to fix the rise time, then how we can fix that. Maybe my panel is working on maximum 5 volt, and the rise time is coming till 10 volt. So my panel can burn, or my motor can burn, right? So that kind of tunings, there is a one toolbox in MATLAB that is called Simulink control design. You can use to tune this kind of parameters also. So we are not discussing about that. Okay, so what I am going to do, right now the output which I wanted I am not getting. So I am going to increase this response time. Also I am going to increase this transient behavior also somehow. Okay, now you see that tuned response is coming one, right? See, after some time, after some rise time, it is settled. Okay, now when I am happy with that, I will update these parameters in a block, and you see that these parameters are updated. Okay, done. Now again I am going to run this for 10 seconds. So transient behavior is slower, so it will run slowly it will run. Now you see there was some spikes. After that my input and output, means the reference and the output which I wanted, both are coming following it. So means my model which I designed, that is perfect now. Means the parameters value which I needed for my PID controller, I got it, isn't it? Now I want to visualize in a two different figure. Just I will go here and I will change this layout. So you see here the first one which you see, that was the reference data. Here it is written, and this is the position, means simulated output. So now you can see I am happy with that. My model is running perfect. Now we can go to test with real data, isn't it? Fine. So till now what we saw, till now we designed a panel. To rotate that panel, we designed motor. To control the error, to minimize the error, we use the PI controller. And again the output was not tuned because there was error. We checked with the input reference and output, right? So for that we use PID tuner for that. We use PID tuner to tune that data, right? Next is to check with real time data. If I have a sun position, if I measure that sun position from some sensors, there is a motion, some kind of motion sensor which track the sun. So that sensor data I have already. So I am going to check on that data, and in this case we will be aware about how to give inputs, user inputs to check that data. Okay. So here you see we are going to take that data, and first of all let's understand that how to do what I am going to do in Simulink. Okay. Just wait a minute. So this is a sun angular data. So sun rise from north to east and end at west to north. So total data which we have of 15 hours first of all. Second thing, it will start from 0 degree and it will it will move around the earth till 270 degree. Okay. Why I use PI controller, not a PID? See, the answer is here. See, when sun rise and it's set to a west side, right? And when again morning will come, then again sun will rise from the northeast, or you may say from the east. Means sun is resetting, but our panel is not resetting, right? Sun is resetting, panel is not resetting. It's not like that next day sun will start rising from the northwest. Again it will rise from the north. So when my panel will move, it will stop here. So my panel is not going back again from here. We have to reset the panel. That's why we use the PI controller. You can understand PI and PID like that. Let's say that I have a drone. I want my drone will go up only, not down. It will go up only. So in that case, we will use PI controller. Why? Integral is used to calculate the past value, and based on that, it will make my drone to go up. Now I want my drone will go down only. In that case, we will design a PD controller. So in this case, PI, because it is going just up only in one direction. So PD controller, what it will do, it will calculate the future value. Based on that, it will let my drone below, downside. Okay. Now, if I want my drone will neither go up nor down, it will be somewhere on height. In that case, I will design the PID controller. So in this case, we don't require a PID controller, right? So you got the flavor that what next we are going to do. We are going to test with original data. Okay. I am going to switch here. Fine. So already we designed with the controller. Let me open that model, the model which we have. This is the model. Here I use this input block because now I want to give input from my workspace, from MATLAB workspace. From MATLAB workspace, from where? Here. I want to give that input. Okay. So this block you will get from source. Here is this block. Just connect this block there. Okay. So this will be a reference. That is the sun position. Let me show you that. Let me show you what data I have when I plot this. So this data is here. You see that with respect to time, sun position is given there, right? So I am going to plot this. That is sun time. Better way not to write. If you don't want to write a code, just from here select the x-axis, then y-axis. Okay. After doing, just go in plot. And there are different kind of plots. Depends on you that what kind of plot do you want. I want a line plot, so I will just simply select the line plot. So this is the input. This is a sun rotation. That is the angular distance of sun from 0 degree to 270 degree. Okay. So this data we are going to give as an input, and at output we are going to check that same graph we are getting or not. If we are getting the same graph, then we can go for hardware modulation, means real plan. Fine. So let me close some other models which I have opened. From here, these are the libraries which we had, and these are some files which files are open. Let me close that, then we will see that. Okay. Let me close this also. So what we did here, we removed this step function and we use that in block, right? Okay. So your next step is what? Okay, just wait a minute. Okay, we have to use this input block. Now how to provide that inputs which I have here, means sun position and sun time. Okay. So what we can do in that case, just go here in modeling. Okay, in modeling, in this setting, that is a wheel sign which you see. Here we have an option for import and export, data import and export. Just go here, take this input, and in a square bracket provide input, means time and position with respect to time, means the same variable name I am using which I have here in workspace. Fine, the same variable which I have. You have to do. So you can check on multiple. If you have your data, if you have your model, you can check it like this. Fine. Now as I told, I am going to run for 15 hours. So 15 into 3600. If I multiply by that, what will I get in seconds? Because here always we provide time as a seconds. Okay. Now I am going to run for 15 hours. And you see that whatever original references also we are plotting, and modulated output also we are plotting in the same figure. Now you see that perfectly it is following. Means the PID controller which we designed, that is working perfect. And if you want to change this layout, it will look like this. You see that that was my original reference data, and the blue one which you see, that is modulated. Means the parameters which I wanted for my controller, the value of torque which I wanted, the value of some constants KD which we saw wanted, that parameters are working perfect. Now there is a one advanced toolbox in MATLAB that is called Simulink design optimization. You can use that toolbox to optimize the parameter and to extract the parameter value. What kind of parameter values you can extract using Simulink design optimization? That to achieve the reference output, what will be a value of J and KD? For that you can go Simulink design Simulink design optimization toolbox for that. Okay, now we got. Now let's say that I have a elevation data also, means what is the height of the panel. Based on that, what if I have to calculate the energy also of that. Okay, I have one more model, that is very simple model, just we are calculating the energy. So here you will see that how to use the MATLAB function block also. Here you will see how to use MATLAB function block. So that is the MATLAB function block. So this block, when I double click on it, what I am doing here, this is function, this is my output, and how many number of inputs I am using in my function, that are 5, right? This is first one, this is second one, third one, fourth one, and fifth one. Five inputs I have. Okay, when I close this, remember one output, 5 inputs. When you provide this, and below you can write whatever you want to calculate. Okay, so you will get a block like this. Just wait a minute. A block like this with 4 as an input, 1 as an output. So see here, in this block, let's say I want 2 outputs. Let's say one output is output. Okay, like this, and let's say that output is equal to whatever power I am getting, I am going to multiply with 2. Now we have 2 output, right? And let me close this. Now you see that we got to link one more output here, right? So depends on you, how many number of inputs are you giving, how many number of outputs are you going to give. Based on that, your block will automatically generate input links and output links. Okay, so in our case we didn't have that. Let me remove this. So there is a power calculation. So what I want to show you here, you can use script also, and I am going to remove this also, I don't want. Okay, you see here is the plot, and when I run this for again 15 hours, so it will take a little time because total seconds are 15 into 3, 3600. Okay, so and it is calculating the power also. So here I provided you see here sun elevation also. Yes, we sun elevation. This sun elevation data I have here, sun elevation on my MATLAB workspace. Okay, and second thing, this elevation, how you are going to give as an input, already you know. You have to go in modeling, you have to go in setting. Fine, and from here you see that inputs we are taking from MATLAB workspace. Time will be same for every, and this is the sun position and this is the sun elevation. We require this sun elevation data to calculate the power of it also. Okay, it is executed, and you can see this is the power. So within 15 hours it shows that how power is increasing, and in the noon you see that power of solar panel, the power the solar panel which is producing, that is almost constant, right? Then when evening is going, so this kind of testings are very important. Okay, I designed whatever reference I gave, I am getting as an output, but power have to be work like that, right? In the morning, from the morning it will start slowly increasing, and then later when it evening come, then it will start decreasing. Okay, power is also showing perfect, like as I wanted. Fine. Okay, let me summarize what we did. We designed panel, we designed the motor, we used controller, we tuned the controller, and we checked that complete model with the reference data, and we saw that the reference which we gave here from here, and we are getting the same here as a output. Fine. Then further we calculated the energy to check that how energy is generated. So we check that also. Some more points which you require to remember when you are designing the Simulink. Let me discuss that, then we will end that session and we will have a question answer session. Okay, the model which we design here, that is some kind of algebraic loop. There are differential equations also, right? Because we have a transfer functions also, there are some differential equations also. To solve that differential equations, we require a solver. So how this Simulink is working? That is a big question. How this Simulink is solving that differential equations? Means from this whole model, the equation which is created as a differential, how it is solving, and which solver will be a base for that model. Okay. So what we can do, just go here in setting, and here in solver there is an option for solver. You see here there are different kind of solvers. Discrete, if you have a discrete model, you are going to choose discrete. ODE 45, fourth order and fifth order, that is Runja-Kutta method, right? ODE 23. Now which solver to choose? In earlier version of MATLAB, we didn't have this automatic solver selection, but now we have this also. When I choose this, based on my model, the solver will be selected automatically. So let me give a brief that how to choose these solvers, and later when we have any session on ODE solving ODE equation, then we can discuss about more. So this kind of solvers which you see, we use in Simulink. And these are some stiff solvers, like non-adaptive solvers are also there. DAE solvers are there, differential algebraic equation solver for Simulink. So if you are using physical modeling, let's say if you are going to design a circuit using active and passive elements like resistance, capacitance, inductance, then you are going to use DAE. Okay, so you know what is difference between Simulink and Simscape? See, just let me go here in library, and let me switch here in Simscape blocks which we have here, which we block we have here. You see, just 1 minute, it is still opening. Okay, you see here. This basic things you have to know, that what is different between Simulink when you are going to use Simulink, when you are going to use when you are going to use Simulink libraries, when you are going to use Simscape library. That is very important. So you see that these are basic elements of electrical circuits, right? And if you are working on gaseous, then you have gaseous elements also. Hydraulics elements are also available. Someone is working on magnetic model, you can choose that. Mechanical models, someone is working on moist air, these are the moist air. Okay, someone is working on thermal, then you can choose these libraries. And further, if I go in electrical, there are electrical motors, electrical machines, and renewable energy. Also, if I go in specialize here, we have renewable energy blocks available. So if you want to work on solar system, you can choose this kind of block. No, okay, I was telling what is difference between Simulink model and this physical modeling. See, physical modeling are bidirectional. Current can go in left side, right side, up and down also. Currents are bidirectional because that are energy signal. Okay, if I am talking about rotational body, so that torque is bidirectional. Okay, torque is bidirectional. So these are bidirectional. In Simulink, signals are one directional. Always remember, if you have a bidirectional model, then you are going for the physical modeling. If your signals have one directional means what? Your transfer function. Time series data, if you have that kind of model which we have as a transfer function kind of models, that are unidirectional, not a bidirectional. Okay, so if you have a bidirectional, if you have to energy signal, if you have as an input, then you are going for this physical modelings. Okay. Okay, let me switch on here. Just wait a minute. So finally, we saw the modeling the physical system, then we designed the controller, we tested the design also on original data. What are the further improvements? As I told that sun rotates from one direction only, sun rise from one direction and sunset on another direction. Again morning will come, in next morning again it will sunrise from the same direction. So sun is resetting, but my panel is not resetting. So once your panel is moved in the evening, you have to reset it again back. But the model which I showed, there is, I didn't use any kind of reset kind of thing. For that, you can use state flow. State flow will help you to reset your solar panel as well. That is the advanced to design a controller. If you want to design an advanced controller, you can use state flow for that. Okay. So now about this, if you are a beginner, if you don't know anything about MATLAB, there are some courses are available on MathWorks website that are free, that are self-paced courses. Each courses are around of 3 hours, and when you complete that course, you will get a certificate also. Okay. So just visit on MathWorks website and start, or you can search on Google MATLAB on RAM, deep learning on RAM, machine learning on RAM. For these 3 on RAM, you don't require MATLAB on your machine. Directly you can execute there like this. Okay. But for Simulink and state flow, which just I was discussing to design an advanced controller, for that you require a MATLAB on your machine also, because you are going to use Simulink. So in that case, when you register on MathWorks, you can generate a trial license and you can install it. It will be for 1 month and you can complete. When you complete that, you will get a certificate like this. Okay, fine. Now question answers. If you have any questions, you just reply me and I will answer that questions.